So this periodic table, let's take a look at what we got. You guys see the jag over here, right? That separates what metals from nonmetals. And let's see, what else? Well, this is 1A, 2A, 3A. They are all A's. So those numbers actually represent the number of valence electrons, right? So with all of these elements, the 1A metals, they lose one electron and they form a +1 charge. Sometimes students, when they get your periodic table for your final in this class or for your Unit 3 exam, you're going to want to mark up your periodic table. These 2A elements, they lose their metals, so they lose their 2 valence electrons and they form a +2 charge. Okay, these three, now remember you got to start with aluminum because that's a metal. The one above it, boron, is not a metal. So these aluminum, gallium, and indium anyway will lose their 3 valence electrons and form a +3 cation. Okay, that works. The title of this actually is Elements That Form Predictable Ions. I usually, in lab sometimes, have called this, you can hang your hat on it. Hang your hat. I don't know where I came up with that. On it. You can hang your hat on the fact that we have a +1, +2, and +3 is what these metals are going to form. You can also hang your hat on, and usually I start over here with the 7A, the halogens, the 7A elements. They have 7 valence electrons. They will pick up 1 electron to become like the rare gas in front of them, and in doing so they will form a -1 charge. So a lot of times people would put a -1 over the halogens. The 6A need 2 electrons to get 8, so they'll pick up 2 electrons and form a -2 charge. Okay, and the 5A nonmetals now will pick up 3 electrons. 5 plus 3 is 8, and then when they pick up 3 electrons, they'll have a -3 charge. Okay, again, you can hang your hat on what these nonmetals will form with regard to their monoatomic ions. Okay, so that's all great stuff, and it's important, actually, kind of in later on, soon in this stuff we're talking about, forming ionic compounds. So starting with the metals, okay, focusing on those you can hang your hat on, those metals, 1A metals, 2A metals, and 3A metals, beginning with aluminum. You can hang your hat on them losing all of their valence electrons, and in doing so, just kind of like we saw with, I think it was sodium, they get basically the rare gas in the period before them. Like for sodium, that was neon. Okay, so actually their new valence shell electrons is not going to be N, but it's in what we call an N-1. And we're going to see an example coming up here. So kind of at a glance, I've got the 1A metals listed here. 1A will lose 1 electron, become a +1 charge. 2A group will lose 2 electrons, become a +2 charge. 3A metals will lose 3 electrons and become a +3 charge. Okay, so again, these are things you can hang your hat on. One of the things that you're going to be held accountable for is to know what charges monoatomic atoms will form. And you already know these. You can find them on the periodic table, and you know because of the group that they're in. So let's take a look at how the electron configuration works. So in the previous unit, we talked about how you can find how the 11 electrons around a neutral sodium atom are hanging out. So I'm hoping this isn't too foreign to you. So the 11 electrons are configured this way. 2 electrons in the 1s, 2 electrons in the 2s, 6 electrons in the 2p, and it peters out with 1 electron in the 3s. So remember, valence electrons are the highest N. N is equal to 3 is the highest N. So we have 1 valence electron. And we've been talking about how the 1A metals will lose their 1 valence electron. So we should be able to write the electron configuration for a +1 sodium cation. So I'm hoping when you see this, you're screaming, oh my goodness. Well, not screaming, but you're like +1. That means that it must have lost 1 electron, -1 electron to form that +1 charge. and the electron it's going to lose is right there. It's valence electron. So you should be able to write the electron configuration for the +1 sodium cation. And the only difference between these is it doesn't have that. Does that make sense? That one electron in 3s. Well, let's go ahead and turn our attention to aluminum. Now, aluminum has 13 electrons. I couldn't think of that. A neutral aluminum will always have 13 protons in its nucleus, and if it's neutral, it will have 13 electrons. And here's how those 13 electrons are configured. So again, these are kind of our inner core electrons, and we have 3 electrons in the n is equal to 3. Okay, so we actually have 3 valence electrons. That's great because it's in 3a. Those are 3 valence electrons. So when aluminum forms a +3 charge, it has lost 3 electrons, and the 3 electrons it lost were those 3 electrons in 3s2 and 3s1. Okay, so does that make sense? The only difference between these two, a +3 charge, and these are the 3 electrons that went away. And again, just so we're all on the same page, these guys right here, okay, these are both the same electron configuration as neon. Now, are the cores the same? Yep, how do I say it? The nuclei of these guys, this is actually still 11 protons, and this is still 13 protons, but it has the electron configuration like neon.